Saturn, the jewel of our solar system, reigns supreme with its dazzling rings. These rings, stretching out over 175,000 miles, are a marvel of cosmic engineering, composed of ice, rock, and dust. They create a spectacle that has fascinated humanity for centuries. These rings are not solid structures. They are a breathtaking spectacle of countless particles, each on its own unique journey around the gas giant. From tiny grains of dust to massive chunks of ice, these particles reflect sunlight, creating a shimmering halo that can be seen even from Earth. This celestial ballet, a mesmerizing dance of ice and rock, has captivated astronomers and stargazers for centuries. The ring's intricate patterns and dynamic movements are a testament to the complex gravitational forces at play. Observing them through telescopes, we witness a dance choreographed by nature itself. The rings of Saturn are more than just a beautiful sight. They are a window into the history of our solar system. Each ring tells a story, revealing clues about the planet's past and the events that shaped it. By studying these rings, scientists can piece together the history of Saturn and its moons. By studying their composition and structure, we unlock secrets about planetary formation and the forces that shape our cosmic neighborhood. The rings act as a natural laboratory, offering insights into the processes that govern the formation of planets and moons. Through detailed analysis, we can understand the dynamics of our solar system better. Join us now as we embark on a journey to unravel the mysteries of these celestial wonders. As we delve deeper into the rings of Saturn, we will uncover the secrets they hold and the stories they tell about the universe we inhabit. Prepare to be amazed by the beauty and complexity of Saturn's rings. The rings of Saturn are primarily composed of water ice. This ice is not a uniform sheet. Instead, it exists as countless particles, ranging in size from tiny grains to chunks larger than houses. Mixed with the ice are traces of rocky material and dust. These particles are remnants of comets, asteroids, and even shattered moons, captured by Saturn's powerful gravity. The composition of the rings is not uniform. The proportion of ice to rock varies, influencing the ring's brightness and reflectivity. This variation provides clues about the origin and evolution of the ring system, painting a picture of a dynamic and ever-changing environment. The rings of Saturn are a stunning display of light and shadow. The ice particles reflect sunlight, giving the rings their brilliant shine. The amount of light reflected varies depending on the density and composition of the ring particles. Denser regions, with more tightly packed particles, appear brighter. The rings also exhibit subtle color variations. These colors, though faint, are visible through telescopes. These variations are linked to the presence of different materials within the rings, such as rocky silicates or organic compounds. The interplay of light and shadow, along with these subtle color variations, creates a breathtaking tapestry across the Saturnian sky. Saturn's rings are not static, they are in constant motion, with each particle orbiting the planet at its own speed. This celestial carousel is governed by Saturn's immense gravity. The closer a particle is to Saturn, the faster it orbits. This difference in orbital speeds creates a dynamic and ever-changing ring system. The ring system is vast, extending outwards over 175,000 miles from Saturn's cloud tops. Despite their impressive diameter, the rings are surprisingly thin. Their vertical height averages less than half a mile. This makes Saturn's rings one of the flattest structures known in the universe. Our understanding of Saturn's rings has evolved over centuries. In 1610, Galileo Galilei, using his rudimentary telescope, was the first to observe these strange appendages flanking the planet. However, his instrument lacked the resolution to discern their true nature. He described them as ears. It was Dutch astronomer Christian Huygens in 1655 who correctly identified these features as rings. Over the centuries, with advancements in telescopes and imaging techniques, our understanding of the rings has grown. Today we marvel at their intricate structure and complexity, a testament to the power of human curiosity and ingenuity. The formation of Saturn's rings remains a subject of scientific debate. These rings, composed of countless particles of ice and rock, have fascinated astronomers for centuries. Their origin, however, is still shrouded in mystery. One prevailing theory suggests that the rings are remnants of a shattered moon. This moon, once orbiting Saturn, met a catastrophic end. This moon, orbiting too close to Saturn, was torn apart by the planet's immense tidal forces. The gravitational pull of Saturn is so strong that it can rip apart celestial bodies that venture too near. The resulting debris, unable to coalesce back into a moon, spread out into the rings we see today. These particles, ranging in size from tiny grains to large boulders, now form the intricate and beautiful ring system. Another theory proposes that the rings formed alongside Saturn in the early solar system. During the planet's formation, material that could have formed moons was instead captured by Saturn's gravity. According to this hypothesis, the material that makes up the rings never had the chance to clump together and form moons in the first place. Instead, it remained as a protoplanetary disk, a swirling mass of particles. Instead, it remained trapped in orbit around the young planet, eventually evolving into the majestic ring system we observe today. Over millions of years, these particles have settled into the distinct bands and gaps that make Saturn's rings so unique and mesmerizing. Saturn's rings are not a continuous sheet of material. Instead, they are a complex structure made up of countless small particles, ranging in size from tiny grains of dust to large boulders. These particles orbit Saturn in a delicate balance, creating the stunning visual spectacle we see from Earth. They are divided into distinct rings, each with its own characteristics. Some rings are densely packed with particles, while others are more sparsely populated. The differences in particle density and composition give each ring its unique appearance and texture. These rings are separated by gaps, regions where the density of ring particles is significantly lower. These gaps can vary in width and are often named after the astronomers who discovered them. The gaps are not just empty spaces, they play a crucial role in the dynamics of the ring system. The most prominent of these gaps, the Cassini division, is visible from Earth with even a small telescope. This division, which is about 4,800 kilometers wide, separates Saturn's A ring from its B ring and is one of the most well-known features of the ring system. The gaps are not empty spaces. They contain fewer particles than the rings themselves, but they are not devoid of material. Some gaps even contain small moons or moonlets that help to maintain the structure of the rings. They are often sculpted by the gravitational influence of Saturn's moons. These moons, known as shepherd moons, can create and maintain gaps by their gravitational pull, which clears out particles from certain regions of the rings. These moons, through a phenomenon known as resonance, can clear out material in specific regions, creating the gaps and divisions that give the rings their intricate structure. Resonance occurs when the orbital period of a moon is in a simple ratio with the orbital period of particles in the rings, leading to repeated gravitational interactions that clear out material. This interplay of gravity and orbital dynamics creates a constantly evolving masterpiece. The rings are not static, they change over time as particles collide, clump together, and are influenced by the gravitational forces of Saturn and its moons. This dynamic system is a beautiful example of the complexity and wonder of our universe. Saturn boasts 7 main rings, each designated by a letter of the alphabet. The rings were named in the order of their discovery, not their distance from the planet. The D ring, closest to Saturn, is faint and diffuse, while the A ring, further out, is brighter and more defined. The B ring is the most massive and brightest of the rings. The Cassini division separates the A and B rings. The F ring, a narrow and constantly changing structure, is shepherded by 2 small moons, Prometheus and Pandora, which confine its particles. Saturn's moons play a crucial role in shaping the rings. Their gravitational pull creates waves and disturbances in the ring particles. The moons Prometheus and Pandora, for example, act as shepherds to the F ring, confining its particles and preventing them from spreading out. The moons also contribute to the creation of gaps within the rings. The gravitational influence of a moon can clear out material in its vicinity, carving out a gap. The Cassini division, the most prominent gap in the rings, is thought to be the result of a resonance with the moon, Mimas. Saturn's rings are a dynamic and ever-changing system. They are a testament to the power of gravity and the intricate interplay of celestial bodies. Future missions, equipped with advanced instruments, promise to unlock even more secrets about these enigmatic structures. By studying the composition, structure, and dynamics of the rings, we gain valuable insights into the processes that shaped our solar system. The rings of Saturn are not merely a local phenomenon. They serve as a model for understanding similar ring systems around other planets and even stars. They are a reminder of the beauty and complexity that await us in the vast expanse of space.